Welcome to today's Explainer. We are jumping straight into what is honestly probably the greatest philosophical mystery of modern physics. We're pulling all of this directly from Werner Heisenberg's incredibly foundational text, Physics and Philosophy. So buckle up, because we're going to explore a glitch in the matrix of classical science. It's a glitch that completely forces us to question the very nature of existence and how our own eyes might actually be shaping the universe.
I mean, just look around you right now. The everyday world feels pretty solid, doesn't it? A chair is a chair, a table is a table, whether you're actively staring at it or not. But what if I told you that at the absolute deepest, most microscopic level of reality, that simple rule just breaks down entirely? We're about to contrast our safe, predictable, everyday world with the downright bizarre quantum realm. It's a place where the simple act of looking at something might literally be creating reality as we know it.
Section 1. The Quantum Paradox, a Crisis in Physics.
Okay, so to really understand this crisis, we have to look at this massive contradiction that popped up at the turn of the century. The basic building blocks of nature, things like electrons and light, seem to possess two completely conflicting identities at the exact same time. It's wild. On one hand, they act like particles. Think of them as localized, solid little bullets that leave super clear tracks in a cloud chamber. But then on the other hand, they act like waves. They spread out over space, they create these complex interference patterns, and they basically just exist as fuzzy probabilities. You can probably imagine how much this absolutely messed with the heads of early physicists. For centuries, right? The classical Newtonian view of this perfectly predictable, clockwork universe was totally supreme. In that world, everything had a definite place, a definite speed. But suddenly, matter and light were doing things that completely defied common sense. The very fabric of objective reality was literally slipping through their fingers. The universe, it turned out, wasn't a reliable clockwork machine anymore. It was more like a shapeshifter.
Move into Section 2. Wave or particle, the core investigation.
This whole question literally kept scientists up at night. Heisenberg himself actually wrote about taking these long, agonizing late-night walks in a park in Copenhagen, having these endless, intense debates with Niels Bohr. He kept asking himself over and over, can nature really be this absurd? Can a fundamental piece of the universe really be a localized point and a spread-out field at the same time? In classical terms, it's just a straight-up logical impossibility.
And, not everyone was willing to accept this quantum weirdness. Albert Einstein, very famously, completely rejected this loss of certainty. He came out and declared, God does not play dice. Einstein clung really tightly to what Heisenberg describes in the text as dogmatic realism. Basically, that's the belief that the material world must have an independent, definite existence, totally separate from whether we humans are observing it or not. To Einstein, an electron had to have a precise location and momentum at all times, no matter what. He just figured our instruments were too clumsy to see it.
Section 3. Complementarity, an elegant solution.
So, how do we resolve Einstein's issue? Well, Niels Bohr steps in with this absolutely brilliant realization. He figured out that the wave and the particle aren't actually competing for the truth. They are just different, mutually exclusive faces of the exact same reality. You absolutely need both descriptions if you want to fully understand the electron, but nature strictly forbids you from ever seeing both at the exact same time. They complement each other rather than contradict each other. And Bohr actually takes this a step further, which is fascinating. He argued that asking whether an electron is really a wave or particle when it's just sitting there unobserved is a totally meaningless question. Heisenberg's text gives a great analogy here. Trying to define the electron without a specific experimental setup is kind of like asking if a location is over Britain or under Australia without giving any sort of geographical context. You just can't do it. The answer depends 100% on how you are looking at it.
Which brings us to Section 4. The observer's choice, forcing reality.
Now, this is where it gets crazy, because this framework puts you, the observer, right in the driver's seat. The detective actively forces the quantum suspect to choose an identity. If you set up an experiment designed to measure a wave, boom, the electron behaves like a wave. If you set up an experiment to measure a particle, it behaves like a particle. By simply choosing the measurement, you are physically forcing the universe to collapse all its possibilities and make a firm decision. Let's actually walk through Heisenberg's famous thought experiment to see exactly how this works under the hood. It's called the gamma-ray microscope. Imagine you want to find the exact precise position of an electron. Step 1, you target it. Step 2, to actually see it, you have to bounce light off it. But to get a really precise location, you need a super short wavelength. So you hit it with a high-energy gamma ray. Well, a quantum of a gamma ray, to be precise. Step 3, that high-energy quantum hits the electron so violently that it permanently alters the electron's momentum. So you gain perfect knowledge of its position, but in doing so, you've completely destroyed your ability to know its speed.
And this just brilliantly hits the nail on the head regarding the core truth of quantum mechanics. We cannot, under any circumstances, simply observe the atomic world passively. There's just no such thing as a detached observer. Our very act of measuring physically disrupts and literally creates the specific reality we're trying to measure. The observer and the observed are deeply, permanently tied together.
Finally, Section 5, a new reality, the philosophical paradigm.
So all of this builds up into what we call the Copenhagen interpretation. And this interpretation just totally dismantles the classical idea of a clockwork universe. It flat out rejects Einstein's dogmatic realism. Instead, it says that before you look, an electron doesn't exist as a solid physical thing. Heisenberg actually borrows a concept from Aristotle here. He says it exists merely as a set of potentialities. It's just a ghostly cloud of statistical probabilities. It is only the physical act of observation that collapses those fuzzy probabilities into a single concrete reality.
Bohr really summed up this profound wisdom beautifully. He realized that our everyday human language and our classical concepts of space and time, they just don't cut it in the quantum realm. And why is that? Because we cannot separate ourselves from the universe we're trying to figure out. In Bohr's own words, when it comes to the great drama of existence, we aren't just mere spectators sitting out in the audience. We are active actors, right there on the stage.
Which leaves us with this final, honestly mind-bending thought to wrap up the explainer today. If the solid matter that makes up literally everything around us, our phones, our homes, our own physical bodies, is built out of these quantum particles whose reality is shaped by the very act of observation, what does that mean for the true nature of the reality you and I experience every single day? It is a huge question that physics is still grappling with, and it guarantees you're never going to look at the world the exact same way again.